Let us now proceed to non-coplanar force system. Now, the resultant force R of a non-coplanar force system can be expressed as, in vectorial form, R is equal to Rxi plus Ryj plus Rzk, where Rx, the magnitude of Rx, is equal to summation of forces in the x direction. Your Ry is summation of forces in the y direction, and your Rz is summation of forces in the z direction. And this states that the resultant force is equivalent to the sum of all the forces. How are we going to determine the magnitude of the resultant force? R is equal to the square root of Rx squared plus Ry squared plus Rz squared. And the direction cosine or direction angles of the resultant are theta x is equal to the arc cosine of Rx over R, and theta y is equal to the arc cosine of Ry all over R, and theta z is equal to the arc cosine of Rz all over R. So let us try to determine now the moment of a non-coplanar force system. And this is expressed in Cartesian vector form as mxi plus myj plus mzk, where mx is summation of moment about the x-axis, my is equal to the summation of moment about the y-axis, and mz is equal to the summation of moment about the z-axis. This states that the resultant couple moment of the system is equivalent to the sum of all couple moments plus the moment of all the forces about any reference point. And to determine the magnitude of the moment, so the magnitude of the moment is now equal to the square root of mx squared plus my squared plus mz squared. We have problem 1. So in problem 1, the resultant of the parallel force systems shown. So we have parallel force systems shown in here is a couple that can be expressed in Cartesian vector form as C is equal to negative 1160J plus 2250K and pounds. So that is the resultant of the parallel force system is a couple that can be expressed in Cartesian form, which is your C is now equal to negative 1160 J plus 2250 K. Now, so first, let us try to determine the resultant of the force systems of this non-coplanar force system. Now, we have since all the forces are parallel to the x-axis. So we have the x-axis, this is the y-axis, and that one is the z-axis. Then the resultant of this force system is now equal to Rx. Therefore, your Ry in here is equal to 0 and your Rj is equal to 0. So let's try to determine now the resultant force, which is equal to Rx, and this is equal to the summation of forces along or in the x direction pointing forward. So let's try to take pointing forward as positive. So we have minus negative 125 and then plus 75, and then we have minus 90, we have plus F1, and then plus F2, plus F2, 1 plus F2, F. So the resultant R is minus 125 plus 75 minus 90 plus F1 plus F2 minus F3. So we have minus F3. Hence, your R is now equal to negative 140 plus F1 plus F2 plus a minus F3. Minus F3. Okay, you try to take note now that since the resultant of the parallel forces is a couple. So if that is now a couple, so we have this is now your R, and this one in here is R. So the resultant force is a couple, and therefore the net R is now equal to 0. Then the net, so that is R in that direction, and we have R in this direction, then your R in here is equal to 0. So from this equation, we now have 0 is equal to negative 140 plus F1 plus F2 minus F3. Or this is equal to 140 is now equal to F1 plus F2 minus F3. I'm going to consider this as the first equation. So let us try to get the moment of the force system about the X, Y, and Z axis. So we now have the moment about the X, Y, and Z axis. So how are you going to determine now the moment about the Z, of these forces about the Z, about the Y, and about the Z axis? Now, so you try to take note in here now that the moment you try to take note that the moment produced by the resultant force is a couple. So the moment produced by the resultant force is a couple. And that couple in here is now equal to minus 1160J plus 2250K. So let us try to get now the moment, therefore, of the resultant about the x-axis is now equal to 0. And the moment of the resultant about the y-axis is equal to this one with J, negative 1160 inch pounds. So that is 8 inches, 8 inches, 8 inches, 10 inches, 10 inches, and 10 inches. So that is inch pound. And the moment of the resultant about the z-axis, so we have your k, that is positive 2250, that is inch pound. So let us try to determine now the moment of the resultant. The moment of the resultant about the y-axis is now equal to summation of moment of all the forces in the original system about the y-axis. So the moment of the resultant about the y-axis is negative 1160 inch pounds. So let us try to get now your F1 has moment about the y-axis. So at this point, I will going to get counterclockwise moment as positive. There is counterclockwise moment as positive. So we have, your F1 will have moment about the y-axis. So we now have F1. Okay, so this is the y-axis. Nandun yung F1. So it goes counterclockwise. So F1 multiply this one by 8, 8, and 8. So that is 24. And then we have F2. So again, your F2 has moment about the y-axis, counterclockwise, F2, and the moment arm is equal to 16. And then we have F3. So your F3, okay, so that is your F3. So it will now going to have clockwise moment. So we have minus F3, multiply this one by the moment arm, which is equal to 24. Okay, so we have minus 125 clockwise moment, and the moment arm is 24. And then we have minus 90. So we still have minus 90, that is a clockwise moment. Multiply this one by the moment arm, and this is equal to 8. Now, the 75 pounds will not going to have moment about the y-axis because it intersects the y-axis. So we have minus 1160 is now equal to, we have 24 F1 plus 16 F2 minus 24 F3. And then the algebraic sum of these two terms in here is now equal to minus 37 20. So that is negative 3720. So we have now, okay, transpose this to the other side of the equation. Then this will now, 3720 minus 1160 is 2560. That is equal to 2560. So this is equal to 24F1 plus 16F2 minus 24F3. So minus 24F3. So let us try to multiply both sides of the equation by 1 over 8. So 2560 all over 8 is equal to 320. 24 over 8, we have 3F1 plus 16 all over 8 is 2F sub 2. 24 over 8 is minus 3F sub 3. So I'm going to consider this one as the second equation. Next, moment of the resultant about the z-axis is now equal to summation of moment of all the forces in the system about the z-axis. Let us still take counterclockwise moment as positive. So the moment about the z-axis is 2250. And that is equal to, so your F2. So that is equal to, your F1 in here has no moment about the z-axis because it intersects the z-axis. So your F2, so this is going clockwise. So we have negative F2, and the moment arm in here is equal to 20. That is 10 and 10. That is equal to 20. So we have your F3 is going counter about the z-axis plus F3, and the moment arm is equal to 30. And then for the 125 counterclockwise, so that is plus 125, the moment arm is 10. Okay, so that is still going counterclockwise about the z-axis. So plus 90, multiply this one by the moment arm, and that one is equal to 30. And then we have the 75 pound, so it will go clockwise about the z-axis. So we have minus 75, and the moment arm in here is 20. So again, let's try. So we now have 2250 is now equal to minus 20F2 plus 30F3 so we now have plus the sum, the algebraic sum of the three terms in here is 2450. That is equal to 2450. So let us try to transpose this to the other side of the equation. Minus 2450 plus 2250 is negative 200. And this is therefore equal to minus 20F2 plus 30F plus 30 F3. So we now have plus 30 F3. Now, plus 30 F3. Now, let us try to multiply both sides of the equation by 1 all over 10. So we have negative 1 all over 10. So this will now become 20 is now equal to 2F2 minus 3F3. So it's 2F2 minus 3F3. So I'm going to consider this one as the third equation. Okay, solving the three equations simultaneously. Then we can determine now your F1, F2, and F3. So first, this is the first equation. 140 is equal to F1 plus F2 minus F3. This is the second equation. 320 is equal to 3F1 plus 2F2 minus 3F3. And your equation 3 is 20 is equal to 2F2 minus 3F3. So if you try to solve equation 1 and equation 2 simultaneously, so equation 1, let's try to multiply this one by 3. So 3 by 140, that is equal to 420. And then, that is equal to 3F1 plus 3F2 minus 3F3. And then, your equation to as is, and this is equal to 320 is equal to 3F1 plus 2F2 minus 3F3. So minus 3F3. So let us try to subtract the two equations. So if you try to subtract these two equations in here, so we have 100 is equal to 3F1 minus 3F1, 0. So we now have 3 minus 2 is F2. So this is now your F2. And minus 3 minus and minus 3, that is equal to 0. And therefore, your F2 is equal to 100 pounds. So let us try to substitute this one in equation 3. So this is your equation 3. So we have 20 is now equal to 2, and F2 is equal to 100 pounds minus 3F3. So transpose that. So we have 3F3 is now equal to 200 minus 20 is 180. Hence, your F3 is equal to 180 over 3, or that is equal to 60 pounds. Then, let us try to substitute F2 and F3 in either equation 1 or equation 2. In either equation 1 or equation 2. So I'm going to substitute this one in equation 1. So from equation 1, so we have 140 is now equal to F1 plus F2, and F2 is 100 pounds minus F3, and F3 is 60 pounds. Hence, your F1 is therefore equal to 100 minus 60 is 40. Transpose it. 140 minus 40 is 100 pounds. Okay, so these are therefore the values of F1, F2, and F3. This is now your problem number 2. Find the x and y coordinates of the point where the resultant of the three forces crosses the plane. So what is therefore the coordinates? So we have your x and y coordinates of the point where the resultant of the three forces, 25 kilonewtons, 35, and 40 kilonewtons, crosses the plane. So we have a circular plate, and the radius of the circular plate is 4 meters. It's equal to 4 meters. Okay, so this point in here, now, so we have 40 degrees with the horizontal, and this is 30 degrees with the x-axis. So your point B is 40 degrees with the x-axis, and point C is 30 degrees with the x-axis. So first, let us try to determine the resultant of the three forces. Now, since again, let's try to look at now the figure. Since all the forces are parallel to the z-axis. So you try to take note. This is your z, this is your y, and this is your x. Then, Rx is equal to 0, Ry is equal to 0, then your Rj is equal to the resultant R. Hence, your R is now equal to summation of forces in the direction of the z-axis, taking upward forces positive. So we have your R is now equal to, so we have minus 25, minus 35, minus 40. So your R is now equal to, so the value of R is now equal to 100, negative 100 kilonewtons. And therefore, the resultant R is equal to 100 kilonewtons, that is down in the direction of the z-axis.